Hey, good morning, afternoon, evening. Mr. Roth here again. Welcome to day 3 of Trig. Hope it's going well. Some of you maybe tried to figure this one out. We're on the back page of that note sheet, that white one. I know I'm a little ahead. You guys are probably right here on your note sheet. This is where we're starting. Before we start there, though, I want to review real quick. So I'm going to jump back a couple slides. So we're going to jump back to this. Remember what a radian is, okay? What is it? The measure of the central angle theta that intercepts arc S, equal in length, that's the big one right there, equal in length to the radius, okay? So the arc length and the radius are equal. So what does that mean? Hey, the radius, if that has a length of r, this arc length of S will be the same as r. When I draw that theta is 1 radian. That's what we talked about. Okay, so that's a big deal. If we can understand that to get 1 radian, that arc length, that length of that arc is exactly the same as that length of that radius. If that happens, we get 1 radii. Then yesterday we did this quick warm-up. Oh, not that warm-up. We had this warm-up and we said, oh, 10 Smarties, radius of 10. Hey, if that's 10 and that's 20, there are 2 10s here, 10 and another 10, that's 2 of them. So hey, what does that make theta? That makes theta 2 radians. That's where we were yesterday. Now let's fast forward to where you guys are. So we're here. It says state a mathematical relationship between the 3 variables. So you want a mathematical relationship. You're going to have an equal sign in here. You're going to have just S, R, and theta in here. Who knows what's going to happen, but you want a relationship there. So I want you to hit pause. I want you to think about this for more than 10 seconds to figure out if you can write an equation that involves all 3 of those. No, I'm serious. Hit pause. Try it. It's going to help you. It's good to struggle a little bit. So think about it. Not text messaging. It won't come instantly to you. Or maybe it did. All right, thanks for hitting pause. Now we're back, hopefully. Hopefully you wrote down something. If you didn't write down something, hit pause again and write something down with an equal sign. Make sure there's an R, a theta, and an S in there. We should have came down to something like this. The way I remember this formula, I say S equals R theta. This is the way you see it in books most of the time. That's what I have memorized. S equals R theta. Some of you might have said theta is equal to S over R. Isn't that the same thing? That's just this solved for theta because you divided both sides by R. If you like that one, use that one. Oh, what happens if you solve for R? Then you said R is equal to S over theta. I don't care which one you use. They all are equivalent. This is the one I like. S equals R theta. This is the one I learned. This is the one you see in the book. What's going on with your formula? So S equals R theta. One thing that's important to remember, this theta has to be in radians. It's an angle. Whoops, I can't spell radians. There we go, that's a little better. It has to be in radians. So whenever you do these problems, you gotta make sure theta's in radians. Because sometimes we're gonna try to trick you and we're gonna put theta in degrees. Because we can measure angles in 2 different units, radians and degrees. When using this formula as S equals R theta, has to be in degrees. Hey, let's do 4 word problems and let's see what's going on. First one, a circle has a radius of 12 centimeters. Central angle theta intercepts an arc length of 18. Find the radian and the degree measure of theta. Let's draw a picture. A circle has a radius of 12. Oh, I can draw a circle. Well, I can attempt. Well, that's a pretty good circle. That might be one of my better ones ever. All right, that's impressive. Well, thank you. I'm glad you thought it was impressive too. All right, so it has a radius, right? Radius of 12 centimeters. Intercepts an arc length of 18. Ooh, 18's a little bigger than 12. So if I put this on here, I'm like, okay, so I have about 12 there, and I need another 6. Oh, that's about half. Okay, so I think that's about 18. A little more than 1. Okay, all right, so now let's see. Now we're trying to find, and it says, hey, what's theta? So that's what we're trying to figure out, okay? Because we have this arc length of 18, hard to see that arc length. Let's see if I can make it a little bigger. There we go. We're looking for theta. Ooh, we just learned this formula, or we can kind of think of it intuitively, but maybe we'll see S equals R theta. S, 18, that's the arc length. R, 12, we're looking for theta. Divide by 12, divide by 12, theta equals 18 over 12, that's 3.5 or 1.5. Okay. All right, so now radians, when we do this thing radian, it's unitless. Okay, well, what do I mean by unitless? That's why we never put any units on radians here. All right, if you've noticed that over the last couple of days, we never write the word radian or that little R after it. Why is that happening? Well, let's take a look. This is centimeters. This is centimeters. So if I put in centimeters on the 18, and I put a centimeters on the 12, and I divide by a centimeter, look what happens to the units. My units cancel. Notice that 3 over 2 now doesn't have any units on. Radians, it's a unitless sort of measure, so we just say that's a theta equals 1.5. Okay, yeah, it's radians. And it makes a whole lot of sense, because if I think about 18 is equal to 12 plus 6. 12 is 1 radius. 6 is a half of a radius in this case, because it's half of 12. So that would give me 1 plus a half, which would give me 1.5. Oh, that makes a whole lot of sense. I know. Isn't it good when things make sense and you understand? You're like, oh, that's pretty cool. I think it's pretty cool too. All right, you guys try number 2. Go. Hit pause. Seriously, hit pause. Draw your circle. See if you can figure stuff out. Thank you for hitting pause. Not quite as good as circle. So you should have had a radius of 8. And it says a central angle of 2.5. All right, so I got to figure about 2.5. Hey, 3 was not quite semicircle. So if I think about, that's pi radians, or 3.14, so 2.5 is going to be somewhere around there. Okay, so I get 2.5, and I'm like, oh, okay, S equals R theta. And we're looking for S sort of deal. So we get that S equals R theta. S is equal to R is 8. Theta is 2.5. Now I got to think, oh, is that radians? Oh, yeah, it is radians. Because remember, theta always, always, always got to be in radians every time. Make sure that thing's in radians. All right. So I go 8 times 2.5. Well, oh, if I think about this, hey, it's 2.5 radians. It's 2.5 radii. So there's an 8 plus a second 8, which would be 16, plus a half would be 4. 16 and 4 would be 20. We're finding an arc length. What's going on here? We have 20 inches. Cool. All right. Hey, I messed up on the last one. Sorry. Let's hit the rewind button. What did I didn't do a very good job reading my answer, my question. It said find the radian degree measure of theta. I come down here. What did I find? I just found radians. So now let's go back and find the degree one. Sorry about that. You guys probably noticed that. Hit pause. You guys find that degree measurement. How do I go from radians to degrees to radians? Go for it. Welcome back. So if I go this 1.5 radians, I got to multiply it by either pi over 180 or, whoops, 180 over pi. I got to think about which one is that going to be. Ooh, this thing here is a radian, so I want the radian on the bottom, which is that pi, and there's 180 degrees. So that's what's going to happen. So now to get this, I'm actually going to take out my handy dandy calculator and just grab it and go, oh, okay, 1.5. I'm going to hit on my calculator, 1.5 times 180 divided by pi, and when I hit that on my calculator, it's going to spit out 85.9 degrees. So there's my other one. So we should have 2 answers to that. Oh, that kind of makes a whole lot of sense, because if it's 1.5, looks like I'm not quite 90. I drew that pretty well. That's pretty good. All right, sorry about that. Let's go fast forward now to number 3. Hey, you guys try number 3. It says find the length of an arc intercepted by a central angle of 60 degrees and the circle of radius 9 inches. Hit pause, go for it. Seriously, hit pause, go for it. back. Oh, we got this 60 degrees. Oh, that's more like 45. Sorry, we'll call it 60 though. We got 60 degrees. We got a radius of 9 inches. So I'm like, oh wait, S equals R theta. And did you realize that this is in 60 degrees, but to use this, we need this angle to always, always, always to be in radians. So hopefully you made that 60 degrees to radians. Ooh, how do I do that? 60 degrees to radians. Multiplied by pi over 180 or 180 over pi? Yes, pi over 180. How do I know that? I want the units to cancel out. I want those to cancel. Degrees are gone. Sixes are gone. So now I get 6 pi over 18. So that looks like pi over 3 to me. So this theta in radians is pi over 3. So now I come up here and I say, oh, S equals R 9 times pi over 3. 9 divided, that just means divided by, so I'm going to do 9 divided by 3. Oh, 9 divided by 3 is 3, so that gives me 3 pi. So that's my exact answer, 3 pi inches. And if I want to hit my handy-dandy calculator, get an approximation, I hit 3 times pi. That gives me 9.42 inches. I guess I should. All right, hopefully that went well. Last one. Oh, where'd it go? There we go. I'll give you a minute to read that one. Alrighty, Emily Sears track at Bluffton College has running lanes that are 1 meter wide. Inside radius of lane 1 is 33 meters. How much longer is the inside of lane 5 than the inside of lane 1 around turn 1? What? Read that one again, hit pause. Cool, see if we can draw a picture. Track, college, oh, I look out back. Oh, I can't see from our room, the track. Out the window. But if I think about, oh yeah, track. I got lanes on a track. Hey, I know what turns of a track look like. The inside one kind of looks like this. There's a turn. And then if I have lane 1, that looks like a lane 1. And then if I have another one, that looks like a lane 2. And then if I have another one, that looks like a lane 3. And I think they wanted to go all the way out to lane 4. And then lane 5 kind of deal. To me, that's what that tells me. Okay? All right, so I'm thinking about the inside radius of lane 1 is 33 meters. Inside radius to lane 1, 33. Not drawn to scale. How much longer is the inside of lane 5 than the outside? Oh, sorry, the running lanes. I have to get that one. Running lanes are 1 meter wide. Ooh, if they're 1 meter wide, the running lanes are 1 meter wide, then this from here to here is 1 meter, from here to here is 1 meter, from there to there, 1 meter, and so forth. I think you get the idea. So if I think about that, then the inside of lane 5 is going to be what? 33 plus 1 plus 1 plus 1 plus 1. That looks like 37 to me. Oh, that was pretty good. Yeah, that's what I thought too. Now it says how much longer is the inside of lane 5 than the inside of lane 1 around turn 1. Oh, well, if I think about the turn, hey, that's a semicircle. I want to find, if I can find the length of that arc, and if I can find the length of that arc, if I could go all the way around, but I'm running out of room there, right? Okay, so if I got to find those two lengths, and then I just got to subtract them because it says how much longer. Oh, well, let's see. Oh, yeah. S equals R theta. Lane 1, so I'm going to say S sub 1. Radius. Ooh, we just found 33. Theta. 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 What kind of angle do we have here? Angle. Angle there. What kind of angle is right there? What kind of angle is that? How big is that? Ooh, that's a semicircle. That's 180 degrees. Oh, no, don't think 180 degrees. That's correct. You're 180 degrees correct. But this thing needs to be in what when you talk about theta? Oh, it's got to be in radians. So 180 degrees. Ooh, that's pi radians. Oh, 33 times pi. Hey, I can do that. 33, maybe I can't write it. Let's try again. Let's try 33 pi. All right, so that's the length of lane 1. Don't you want to decimal it? Nah, we can use 33 pi. Okay? Actually, it makes it easier if we just use 33 pi. Because then if I think about the inside lane of lane 5, radius, 37, angle, pi. So now what do I have to do with those two? How much longer is lane inside of lane 5 than inside of lane 1? I just got to find the difference. How do I find a difference? 37 pi minus 33 pi. That's pretty simple. I don't need a calculator to do that. That's just what? 4 pi. 4 pi what? 4 pi meters. Fantastic. If I want an approximation, then I take out my handy dandy calculator and I hit 4 pi, and that gives me 12.57 meters. Fantastic. I hope that went well. If you didn't understand something, go back, hit rewind, try again, see what's going on. Okay? Now your job is to finish that note, that worksheet that you picked up today on the way in. So good luck. If you have questions, ask your neighbor. Thanks for tuning in. Have a great day.